Hi friends, thank you very much for joining, and yes, so I'll try to tackle your questions one by one. Again, we'll start the session itself in a couple of minutes. So Bitu says you have not explained symbol table in your course. That's not true, Bitu. So let me start sharing the screen. I can tell you exactly where it is because I remember when I was recording it. So let me just go here, gate.applied roots. I can tell you exactly where it is because I just referred through some of these notes earlier. So if you go to compiler design, just go to compiler design and overview. This is video number 19.3. Let me share the screen. Right, so look at this. This is symbol table and error handler. Right, in this video we actually show you how to construct. We actually show this example from Wikipedia, where we take some simple C code and actually how the symbol table itself is built. So I think you should double check the videos before you say something is missing. Okay, hope that helps. Cool. Let's go into the videos themselves. Oh, the voice is low. Okay, let me just increase the volume. Just a second, please. Okay, I'll just increase. Is this better now? Is the volume better now? Is the volume better? Is the volume better now? Some of you said the volume is a little low. I just increased the gain. Can you please confirm if the audio is all right? Just so that I know that there are no glitches. Okay, cool. Very good, very good, very good. Deepyan, I didn't understand what you meant by it. CD, we have 2 sessions. And again, now we are doing 2 sessions a week instead of 1 session a week. So that's why we are trying to spend more time and break it up into pieces. Every live session we are trying to cover anywhere between 2 to 4 marks depending on the paper itself. So I'll tell you why we broke CD into 2 parts and why we broke it logically into 2 parts when I start the session. Okay. Okay, let me look at the audio is fine. Any update on the syllabus for GATE 2022? We don't have the official announcement except that IIT Kharagpur will be the organizing institute this year. So till the time the official syllabus is published in a brochure, we do not know the syllabus. Again, there might be less than 5% change in the syllabus. Last year we had some additional concepts like data flow analysis and compiler design, and things like intermediate code generation, code optimization were clearly called out. And we also saw like 3 to 4 marks, 2 to 4 marks, depending on which set you got last year from some of these newer topics. So if there is a change in syllabus, we will react quickly. 95% of this, syllabus doesn't change every year. The people who are conducting GATE are not foolish. They don't change the syllabus every year. They might change the syllabus slightly once in every few years. If they change it, we'll react quickly. Don't worry about it. Cool. When will they announce the new syllabus? I don't recall exactly when they announced last year. I think it was in September if I'm not wrong. But don't worry about it. Like 95% of the syllabus is the same. Sometimes even 99% of the syllabus is same. Just one topic is added or removed. I think last year some topics from computer networks were removed last year. Right? So some topics get added, some topics get deleted. So don't bother too much about it right now. Okay. So a good question from Datta, which is how can a self-study student use your free notes? So if you're preparing on your own, the free notes can give you a glimpse on what topics you should cover, how much importance you should give to each of the topics, and have you covered all the topics or not. I think that's what it will help you. It also reduces your time. Again, if you're reading from standard textbooks, please ensure that all the topics that are there in our notes are covered thoroughly, and more importance is given to those topics where we have covered in more detail. Right? That's the core idea there. Again, we'll start the session itself in a minute or 2, and I'll answer your general questions at the end of the session like every other session. Okay. Okay, so Harsh asks a very nice question. Practice tests with a thorough revision or just after completing the last video? A very nice question, Harsh. What we would recommend is, suppose you have like some 7 hours or 10 hours of content. Please go through the content. Whatever notes you have for this content, revise it quickly, because it's just very short amount of content, right? Just revise it quickly and then go to the practice test. That's a better scheme of things to do. Okay, so let's get started, folks. Without any further delays, let's get into the session today. Just a second, please. Let me start sharing my screen. Is my screen visible? Just wanted to make sure that things are okay. Can you please confirm if my screen is visible or not? Okay, I can see my own screen on the feedback loop. So I'll answer the general questions, since most of the students who are here are for compiler design interactive questions. I'll answer your questions at the end. Okay, some questions about notes and things like that, I'll spend some time on that at the end. So today is the first session. Again, we've already pinned the whole live session schedule itself. We are on the 25th of May. This is compiler design live session 1, which is a public session, and we are covering basic concepts like syntax analysis, syntax directed translation, basics of compiler design, parser, etc. Right? In the next session, we have other concepts which were given more focus in from last year onwards. Okay, cool. So from these concepts, from lexical analyzer, syntax analysis, SDT, etc., you can expect 3 to 4 marks. Earlier, we did not encounter a lot of marks or lot of questions from other topics. Again, if you see last year question paper, there were roughly 7 to 8 marks depending on which set you got from compiler design. Traditionally, earlier, if you see the earlier years, we only got about 4 to 5 marks from compiler design. But from last year, because new topics like data flow analysis and more importance to code optimization, things like runtime environment, some of these concepts got added, the weightage to compiler design also increased. And that's actually good for students if you think about it. So a quick overview of compiler design itself. So these new topics which got added last year. They're already covered in Applied Gate course thoroughly. Last year we had about 7 to 8 marks. The best thing that they're giving more weightage to compiler design is that, remember, compiler design along with theory of computation, there is a lot of overlap conceptually, and they're some of the easiest subjects to score in. So given that they're giving more weightage to compiler design, like last year, I think there were like 9 to 12 marks for TOC and 7 to 8 marks for compiler design, which means if you just studied these two subjects, you got like almost close to 15 to 20 marks, which is a pretty good number if you think about it, right? Remember, compiler design at its very core is an easy to score subject if you know the concepts and steps. The most important strategy in compiler design is please follow the steps carefully. If you know, because whether your parse tables, right, whether you're drawing the DFA related to the grammars that you have which help you build the parse table, if you just follow the steps, like brute force following the steps, you can score almost like 6 marks out of these 8 marks very easily, right? So the only trick in compiler design is, or the most important trick is to follow the steps. Okay, so let's go with the first question. Okay, I hope this is clear. Again, some of these questions can be lengthy, so please take time and think through them. Most of the questions in compiler design tend to be easier. Again, please focus, as our mentors are saying in the chat window, please focus on solving the problems, because that's why we are here. I promise you, we will spend some time discussing general Q&A at the end of it. Most of compiler design is just about following the steps in a brute force manner. Let's solve the questions, folks. Again, this is an MCQ, so please be careful. I already see different answers in the chat window. So please revisit your answers and see if you got them right or wrong. Obviously, both answers can't be right. I typically see two options in the chat window being highlighted. Obviously, both can't be right. So please revisit your answers. Let's take 30 more seconds. This is a simple problem if you're careful with it. I see three options being predominantly chosen. Remember, it's an MCQ because we have not put that MSQ label here. Okay, so let me answer it for you. Actually this is an easy question. This is like a 1 mark question, the basics of compilers, right? So first, there are three options, and which of these are true? The input to a syntax analyzer is a stream of lexemes. That's not true, right? Because if you see the basic concept, you have code. The code is now broken down into lexemes. Lexemes are things like float. If you have a number like 2.36 or a number like 126, those are called lexemes, right? So the lexemes are actually analyzed by the lexical analyzer, right? So they're typically analyzed by the lexical analyzer, and the lexical analyzer now generates tokens, right? Like ID, like let's say type, that it's a data type. Suppose in C, if you have this, right, int C, so it will recognize that int is a type, right? It's a data type. So instead of int is a lexeme here, but int is a data type, right? So all your tokens are generated. The tokens are what are used by the syntax analyzer, right? So the syntax analyzer looks for the correctness of the grammar, or it checks the syntax basically using tokens, not using lexemes, right? So the input to the syntax analyzer is not a stream of lexemes, it's actually a stream of tokens. So obviously one is incorrect, number one. Okay, so okay, let's go to the next one, which is the total number of tokens in the given code fragment. It's very simple to count. Let's count step by step, right? This is straightforward. Int is one token, number of tokens, right? Yes. 2, 3, 4. The first row has 4. This row has only one token. What about this row? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 tokens here. What about this? So 1, 2, 3, this is one whole symbol. This is not equal to symbol, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So total 10. Again, double ampersand also is one logical unit, right? If you think about it in terms of tokens. So double ampersand will generate one token. Let's look at this. This is where a lot of people will make a mistake. So printf is a function name, 1, 2. This whole string is one token. So 1, 2, 3, 4, 5, 6, 7. So this is 7. Else is just one token. So 7. Now you have printf 1, 2. This whole string is 3, 4, 5, 6, 7. Again 7. The last parenthesis is 1. Right? Sorry. So this is 1. I'm sorry. My bad. So this is 1. Else is 1. Okay, so if you count these, so 7 plus 7, 14, plus 2, 16. So this is 16. 16 plus 4 is 20. 20 plus 10 is 30. 30 plus 10 is 40. So you get the 40. So this statement is true. Very simple. So the first statement is incorrect. Second statement is true. Because you have none of the above, you have to be careful, right? You can't just say, hey, because 2 is there and 1 is not there, I'll just say B is the answer. So because none of the above is also there, you have to be careful. Next is about symbol tables. Now, what is this question? We were just talking about symbol tables when this live session started, right? So we described in the course videos also using an actual code example in C that I was just showing you at the very beginning. we take some code snippet in the course videos and actually show the symbol table as an example from Wikipedia. So what do you have typically in a symbol table, right? You have the symbol name, right? What is the symbol name? You have the data type of the symbol, and you have the scope, and you can have other data also, right? One of the most important things that you should be able to figure out is, given any symbol name, right? Like I'll just show you this, right? If that helps you. Just a second. There is a very nice example on Wikipedia that we use. Sorry. There is a very nice example on Wikipedia that I was just referring you to a while ago, right? Just give me a second. Wiki symbol table. Okay, cool. As an example, we have it. Yeah, here is an example, right? Look at the symbol name that you have here, the type, what data type it is, what is the scope. This is what a C compiler parses. Again, this is actually C code. This is how the symbol table is built if you're implementing a compiler for C language, right? So again, we discussed the same example in the course videos. It's very simple. So given a symbol table, all you need to do is you need to be able to search for that symbol, right? If you want to search for a symbol, you can do a linear search. Look at this. You can do a linear search. You can do a binary search, or you can do a hash table based order of one search, right? These are the three ways you can implement a symbol table, right? So if you implement it using a linked list, you will have a linear search. The time complexity of searching into the symbol table is larger, but it's not that you can't implement it using a linked list. You can. Nobody is stopping you from that, but it's not an optimal implementation. Similarly, you can do it using a binary search, because one of the most important things that you do in a symbol table is you insert into a symbol table. You could delete from a symbol table. Similarly, most importantly, you want to search from a symbol table, right? All these operations you can do either linked list, binary search trees, or hash tables. Actually, hash tables are actually what are used in most real world compilers, right? Because hash tables can help you search faster, right? So this statement is also true because symbol tables can be implemented using linked lists and binary search trees. So statement 2 and 3 are correct. Very simple. The nice part about this is this is combining concepts from basic data structures and compiler design. This option is very interesting from that sense, right? So 2 and 3 are correct. So option B is correct. I've seen some of you choose option C. Probably, I think you got confused with this option. Lexemes are not given to syntax analyzer. It is tokens that are given to syntax analyzer, right? Simple question. I hope this is clear. Okay. Cool. Okay, sounds good. Again, here I'm assuming that you know these concepts. That's why I'm not explaining the concepts from scratch. In a problem solving session, the fundamental assumption is you know these concepts before you come in. Okay. That's why we put the schedule first. Okay, this is going to get slightly tricky. Let me move my, okay. So this question is slightly lengthy. Please read it and solve it. It's not, okay, tackle it, please tackle it. It's a lengthy question, so please read it carefully. Again, this question, some of you are planning to leave this question. Please don't leave it. While there will be questions like this, especially from compiler design, that looks daunting. That looks like a very big question. But when you start solving it, remember the key technique of compiler design. Follow the steps carefully. I mean, this is more like the good thing with compiler design is if you know the stuff and if you carefully follow the steps, you will get full marks. It's that simple. You just have to follow an algorithm. We discussed lots of examples about how to construct an LL1 parse table. Right? There is basically a couple of simple rules that you have to follow. So just follow those rules, follow the steps carefully, you will get the answer. This is also an MCQ. Just follow the steps. If you don't know the steps, you have to go back and prepare. Good. I'm very happy. People who followed the steps will get the answer easily. I see a lot of you doing a good job. Very good, folks. If you don't know the steps, you can't solve it. It's that simple. Questions like these could be given for 2 marks also, because it takes a little time to solve it carefully. Some of these could also be made trickier. I think almost all of you who know the steps got it right. Very good, very good. Yes, somebody is asking, can we just be brute force? Yes, you have to be, because it could so happen that some of these options are given tricky. So follow the steps carefully. Brute force is what you do, right? How do you construct a parse table? You have to go through the steps. There is no other way. In some instances, while there can be shortcuts, the shortcuts can also be traps. There are simply 2 rules to construct LL1 parse tables. Okay, so just in the interest of time, because for me to explain this would take some time, whenever you want to construct an LL1 parse table, first write the first of each of these symbols, right? So what is first of S, right? First of S is, okay, obviously this symbol, right? So it is this open parenthesis. What about first of T? Okay, so I'll just write first of T. I'll just say first of T, right? F of T. What is first of T? First of T is first of C union closed parenthesis, right? So there is closed parenthesis and first of C. Let's compute what is first of C in just a while, right? So anyway, let's compute first of C otherwise, right? What is first of C? 0, 1 and first of S, right? So you have 0, 1 and what is first of S? Open parenthesis, right? That is first of C. So when you're computing first of T, you have closed parenthesis and first of C, right? What is first of C? 0, 1 open parenthesis. Similarly, what is first of A, right? This is simple again. First of A can start with the semicolon, or you could also have this closed parenthesis, right? So simple. Okay, semicolon, comma, closed parenthesis. What about first of B? First of B is this closed parenthesis and first of C. What is first of C now? First of C we already know, right? First of C is 0, 1 0, 1 open parenthesis. So 0, 1 open parenthesis. You have computed the firsts of all the non-terminals. This is the first step. Just follow the steps. Then there are literally 2 simple rules, right? What are the rules? The first rule says if you have a production rule like this, which is A generates some alpha, where alpha is a string of terminals and non-terminals, then in your table, let's call this table as T, right? In your table, in the cell A comma A, you will place this production rule, right? You'll place this production rule in this for all A that belongs to first of alpha. This is the first production rule. Again, there is one more production rule if the first of alpha contains epsilon, right? And we don't have that. We don't have any epsilons here. So we don't have to apply the second rule. So there are literally 2 rules. This is the first rule of constructing LL1 parser. The second rule basically says that if, again, that is irrelevant in this context, but again, we describe this in lots of detail with examples in the course videos. if this contains epsilon, right, then what do you do, right? This is not relevant in our context. So you just apply the first rule. That's it. You're done, right? Now let's apply. So you have this. Look at this. This is S1. So the table entry for S comma 1. Now observe one thing, right? Is 1, look at this, because this is the table entry that we are looking for, right? A is S, this lowercase a is 1, right? Is 1 the first of any alpha here? Look at this. Is first, look at this. Does f of s, if you see first of s, it only contains closed parenthesis, right? S, look at, there is only one production rule. S generates this. And what is the first of this? The first of this is the open parenthesis. I'm sorry, right? There is no possibility of having 1 here, which means this entry has to be blank, right? There can be no production rule here. So you can simply eliminate option A and B. Now let's look at 2, right? It's actually very simple. Look at 2. What is the table entry here? Look at this. What is the table entry that we are looking for? This is table entry corresponding to the non-terminal T and the open parenthesis, right? So this is what we are looking for. What production rule should exist here? Now simple. T comma open parenthesis. Let me just draw this carefully. T comma open parenthesis. Is open parenthesis, look at this, when T generates this, look at this, T generates this or this is closed parenthesis, so that's already taken care of here. So T generates CA. So what is the first of CA? First of CA is first of C. What is first of C? First of C contains this open parenthesis, which means this will, again, T generates CA has to be there in this entry. So this entry will be T generates CA because the first of C is open parenthesis, right? So now let's look at, so we've eliminated these two options. Hey, this option can't be there. 2 cannot be this. So you've eliminated A, B, D. You're only left with C. So you go with C. Again, you don't have to check 3 and 4 also. You can just simply eliminate, and you're solving the problem in roughly in a little faster time. Again, if you check, you'll see C will have B generates CA. You'll see that 4 has blank. Again, here, please understand that I'm going step by step because it could so happen that the examiner has given a slightly tricky question, and if you don't go step by step and jump to the answer by just looking at some simple patterns, you can fall for it. I always recommend, even when I solve problems in compiler design, even if it takes a little time, I just try to be more thorough, go step by step. Okay, so most of you got it right. So the answer here is C. Very simple. If you know how to build an LL1 parse table, it's straightforward. Cool. So let's go to the third question. Again, just before that, this second question is sort of like an easy to medium problem as far as gate is concerned, and most of you can get 2 marks if this is asked for 2 marks, right? So here comes a more interesting problem. This is the third problem of the day. Folks, please focus on the topic of discussion here. Because if you ask a random question, I will not be able to answer now. I will answer at the end, not now. Even our team also is trying to answer the follow-up questions in general. Somebody is asking about something in COA. Thankfully, somebody answered it's covered in OS. Again, let's focus on CD, please. Please be careful with this question. It's okay. Take time. You could be asked this question for 2 marks. That's okay. Please don't make a mistake here. I already see a lot of answers that people are putting in. It's okay. Please revisit your answers. Take time, follow the steps. Please draw that finite automata like a graph-like structure that we draw. It's okay. Draw the full parse table, or at least part of the parse table where you're a little doubtful. It's okay. Because we have seen lots of students who make mistakes because they don't follow the steps, especially for problems like this. I see almost every possibility being put in the chat window. The only way you can be 100% sure and you don't fall into the trap of the question is to draw the parse table. This is also an MCQ. This is a slightly medium level hardness. The reason it's medium level hardness and lengthy if you do it properly. Please follow the steps. I see a lot of incorrect answers. I think 90% of you will not get the marks with the answers that you have put in the chat window, I think. The reason I'm saying this is because I drew the whole parse table just to be double careful. I'll show you the parse tables also. I think I see all the options B, C, D, except A. Everybody is saying every other option could be correct. Harsh, good job. I think you went through the steps. Again, I'll give you a few more seconds. Please revise your answers. Many of you got it wrong. Again, I may be wrong. That's possible. Take your time, please revise your answer. In GATE, if you see a question like this, which you think will take more time, but if you know the steps properly, go tackle it. Probably you'll get this, you'll get like 2 marks free of cost if you know the steps. I see people who have taken slightly more time get more accurate answers. People who are answering now, more recently, right? We have spent more time probably drawing the whole thing, get more marks, because if you get it incorrect, you have lost marks. Simple as that. And there will be negative marks because this is an MCQ, right? This is an MCQ, right? You not only have lost, you not only have got the answer incorrectly, you also lost marks because of negative marking. Okay, so let me go step by step. Okay, so if you see, so you're given some grammar and you're being asked about 3 things. You're being asked about LL1, you're being asked about LR0, you're being asked about SLR1, right? We know that every language which is LR0 is also SLR1. Right? We know this already. So we have to first check for LL0, then let's check for LR0, then let's check for SLR, because all the possibilities are, or at least a good chunk of these possibilities are here. Okay, so first and foremost, look at this. So if you see, S generates something which is starting with lowercase b here, lowercase b here, right? First observation, right? If you think about LL1, right? If you think about LL1, again, even without drawing the parse table, you can tell the answer, because when you're constructing the, so let's go step by step, right? Let's go with LL1 first, right? So when you construct the parse table, look at the table entry for S comma B, right? Look at this. S comma B. If you remember the rules of LL1, what is the first of this? The first of this will contain B. So there is a production rule whose first will contain B. The first of this production rule also will contain B. Again, if you think about how do you construct LL1 parser table, so in the table entry for S comma B, you will have to place two production rules. S generates BAC and also S generates BDA in the same cell, in one cell, which is the Sth row and Bth column. That's what I mean when I say in table. S comma B basically means in Sth row, Bth column, you have to place both of them when you write the parse table for LL1, which means there's a conflict here, right? Obviously, no brainer, right? So obviously this is not LL1. Most of you got that right. So it can't be this. Most of you chose between these three options. Okay. So we know that it is not LL1. Okay. So that part is decided. Okay. Now what about LR0? Again, even for LL1, I would recommend that you draw the parse table if time permits, because that way you will not make mistakes. Again, if you solve enough problems, if you like in our course videos and problems, we have built LL1 parser table, LR0 parser table, and SLR1. Again, if you know how to build LR0, SLR1 is trivial, right? It's actually a trivial extension, right? You place the reduce rules only in some places and not in all the places, right? That's it. So if you know how to do it, you can find these patterns and figure it out. But I would always solve it by drawing the whole finite automata or the graph for LR0, which I'll also use for SLR1. So I'll show you the whole graph that I've drawn, right? So this is the whole graph, right? I've just pre-drawn it just in case the time doesn't permit, right? We start with, again, you know the whole story, right? You know how to draw this finite automata. Again, this is something that we have covered in the course videos. Even if you're following a standard book like Dragon book for your own learning, this is like standard, right? You add this new production rule with a dot and you keep generating all of them. Again, all of your shifts and reductions are there here, right? And now given this, again, what am I doing here? I'm building the LR0 parse table. That's what I'm starting with. Now, before you even build the LR0 parse table, you can see a few problems. Again, you don't have to build the full LR0 parse table if time doesn't permit. Okay, while I've built all of it, I'll show you. You'll see problems immediately in I4. Look at this. When you build the parse table for LR0, you see a problem here. Similarly, you can see a problem here also. Because in this state, because the dot is in front of C, I can do a shift or I can do a reduction because the dot is at the end. So there is a possibility that I'll have a shift SR conflict, basically, a shift reduce conflict here. There is a possibility that I can have a shift reduce conflict here also, right? Now here I have only reduce, here I have only reduce, here I have only reduce, only shift. This is anyway only reduce, this is only shift operations, So in my whole parse table, I should be more careful with I4 and I7, right? Rest all I can completely skip if I don't want to go full depth. These are the areas of problem that I should be careful with. So let's build the LR0 parse table. Okay, I've built the whole parse table. Again, the problems arise in I4 and I7. Again, you can skip building the rest of the parse table, right? You can skip building it. You can just build the I4 and I7. How do we build it? Look at this. We write, see, when you're building an LR0 parse table, right? You write the reduction rule everywhere, right? This is reduction rule 5. So what is the reduction rule here? Look at this. The reduction rule here is A generates D dot. So if you start giving numbers to it, this is the first S generates AA is 1, S generates BAC is 2, S generates DC is 3, S generates BDA is 4, S generates D is 5. So the fifth production rule, right? So R5. So how do you construct LR0 tables? You place R5. Again, this is something that we explain in lots of detail in the course videos. So I'm just summarizing it in short. For I4, you place R5 in all these places. Similarly for I7 also, you place R5 in all these places, right? Because what is I7? Let's look at I7 here. What do we have? I7 also has this reduction because of A generates D dot, right? Now comes the fun part. Now you'll also observe that, look at this, because in I4, when I see C, like when I have C, I can also do shift 8. I can also shift to 8th state. Similarly in I7, when I see A, I can shift to state 10, and that's clear from the diagram here. Look at this, that's clear from the diagram here. I'm in I4, when I have C after the dot, I can do a shift and I can go to S8. Similarly, if I'm here, I can shift, look at this dot can shift over the A and it can go to state 10. So if you simply draw this, again, you can answer it with some practice, you can answer it directly from this finite automata or the graph itself. But if you're learning this in the first iteration of learning, always draw the parse table, especially of those states that you're more concerned about, like I4 and I7. You'll quickly see that there is an SR conflict here, there is an SR conflict here, right? So this says that this is not an LR0 parser. Sorry, this is not an LR0 grammar. Problem solved. Now, since you have already constructed LR0 grammar, constructing SLR1 is trivial, right? So what, again, I also have the SLR1 parse table here. So what is a simple rule? How do you construct SLR1 parse tables if you have LR0 parse tables? It's literally one thing. You simply place the reduce operations, right? You simply place the reduce operations or the reduce productions, okay, in follow of LHS. Again, this is something that we explain with examples and things like that. We show examples of grammars which are LR0 but not SLR1 and things like that in the course videos. But even if you do this, remember, even if you do this, so then what do you have? You have only R5 placed here and here. You don't place it across the whole row. Similarly, you have R5 placed here and R5 placed here. But even with that, you have an SR conflict here, you have an SR conflict here. Even though you're not placing the reduction rule in the whole row for all the terminals, even though you're not doing that, you still have an SR conflict if you draw the parse table for SLR1. So this is also not SLR1. Again, you don't have to do this for all the states. You just have to do it for I4 and I7, which seem problematic from this finite automata or graph. Simple structure. Again, this problem takes time. The reason I said this problem is time taking is because it's better to draw this to avoid silly mistakes. I've seen a lot of you who probably did silly mistakes on this problem because you didn't go thoroughly with this, right? You just have to, again, this problem is actually easy, right? If you follow the steps, this problem is easy, but we would rate it as per GATE standard as medium plus lengthy. And such problems could be asked even for 2 marks in GATE, because even the people who are setting the GATE paper know that, again, if you give a slightly tricky question, the people who go through the process properly will check for LL1, LR0, SLR1. They check for all these carefully. I would recommend, especially in the first iteration of your learning, please follow the steps to avoid silly mistakes. Again, I see that in the data here, right? I see the same thing here. So the right option here is, okay, let's look at the options, right? Not LL1 but LR0, no. LL1, LR0, no. Not LR0 but SLR1, no. It's neither LR0 nor SLR1, right? D is the right option, right? Most of you, I think, have said C. Some of you even said B, right? So again, one observation that I've made in the chat window is, one thing that I've done here is, one thing that I've observed in the chat window is people who have taken little more time have got the answer D because probably they followed the steps more carefully. At this point in your preparation, following the steps is more important than just brute force speed. Okay, cool. Let's go to the next question. Okay, so I have all of these details here. Okay, so this is also, okay, cool. Let's tackle this question now. A very standard type of question in GATE again. Compiler design is all about following the steps. I'll write it here for you. follow the steps carefully. If you don't know the steps, you should go back and revise it from your notes or from the course videos. If you know it, it's straightforward. Let's not go for speed, let's go for accuracy. Compiler design questions typically tend to be easier in Gate. There will be very few medium or hard questions typically in Gate. Most questions are easy, some of them can be lengthy. Again, most of these questions are based on previous year Gate questions. Good, very good. Again, this is an easy question, folks, typically like a 1 mark question. Very easy to score. Again, just follow the steps. I think almost everybody got it right, which is good. Everybody who put their answer in the chat window, I think, got it right. Very good, very good. Okay, let me answer for you. So here we are given a left recursive grammar because S generates S here, U generates U, T generates T. If you see the options, you see right recursive grammars. For example, this is right recursive, right? Similarly, this is right recursive. So if you see the options, all that it's asking for is you're given a left recursive grammar and you want to change it to a right recursive grammar. And for that, the steps are very simple. There are fundamentally 2 steps that are useful in this context. Again, we have derived these steps in the course videos also in lots of detail. So if you have a production rule like this, A generates, let's say, A alpha slash beta 1 slash beta 2 slash beta 3. Let's assume there is this production rule. This is left recursive. You can replace this left recursive production rule with 2 production rules. A generates beta 1 A dash, right? It's a new symbol, slash or beta 2 beta 2 A dash, beta 3 A dash, right? This is one, beta 3 A dash. This is one production rule. Other production rule is A dash generates either epsilon, yes, A dash generates epsilon, or A dash generates alpha A dash. This is right recursive. This is not left recursive. So this is a very simple rule to take you from left recursive to right recursive. You just replace this wherever you have left recursion with this. That's it. Your problem is solved. So if you just apply these rules here, right? So you have S generates SAS slash U. So for this, what can we write? We can just simply say S generates, because there is U here, U S dash, right? Because U is like your beta here, right? Your S is like your A, your alpha is nothing but AS, right? That's what it is. Again, just try to map it, right? So S generates U S dash, then you have S dash generates, you have beta AS, right? You have beta 1, so which is AS, S dash, and epsilon, right? And epsilon. That's it. You're done. So S generates these 2 rules. Now from this, can I eliminate something? I can eliminate this, obviously. This goes because you have AS dash. This is not how it works. It has to be ASS dash, right? So option A I can completely eliminate. Okay. Let's look at U now. Okay. So U generates. You have the recursion here. So you can say U generates, you have T here, which is like your beta. So T U dash, I'm just following the steps. I'm just following these steps here, right? So it is T U dash. And what about U dash? U dash generates epsilon or lowercase u, uppercase u, U dash, right? That's it, right? So from this, can you eliminate something? U generates this, okay? Yeah, so this is already eliminated. I'm sorry, this is already eliminated. I don't have to worry about it. Let me just cross it. Can I somehow eliminate this? T U dash, U dash epsilon. This could be the answer. What about this? This could be the answer. This also could be the answer. So I'll have to do the T, right? So let me do the T. So now next I have T generates, right? Because I have this whole thing. T generates, okay, this T dash, right? And or lowercase t T dash or F T dash, right? These three things will be there, right? Because you have T, F and this is where the recursion is, okay? So T dash generates N T dash or epsilon. So where is this present? Okay, this is present here, right? So look at option C now, okay? T dash generates this, right? So this seems correct. U dash epsilon. I'm just cross checking it. S generates US dash, US dash, okay? S dash generates AS. Again, the symbols can be slightly tricky. I make silly mistakes like this. That's why I'm double checking. U generates this. U dash generates this. Yeah, S generates this. So option C is the right option. Problem solved. Right? Simple. Very simple solution. Nothing fancy or hard. What is the difference between option C and option D? I'm just looking at these. Is there a difference between option? Oh, there is N here. Okay, this should be epsilon. Okay, this should be epsilon. Sorry. So this can't be true. Okay, so option C is the right option. Right. They almost looked similar. Like I make these silly mistakes that I oversee these small differences. I'm bad at that. That's why I'm being careful. This is an easy question. It's actually a dead easy question. If you know these rules, you just apply them. Cool. Let's do one interesting problem on syntax directed translation. This is also an easy problem, but this can be made tricky very easily. Again, most of compiler design is easy, folks. Again, for most of these questions, you can take between 2 to 4 minutes in the gate examination. But please don't worry about speed now. Please worry about accuracy. Because gate is not so much about speed like, let's say, bank exams. It's more about accuracy. If you know how SDT or syntax directed translation works, this is a straightforward problem. This problem, while it is easy, it can be made tricky. I've seen a few variations of this problem where the examiner can make it tricky very easily. I know that some students will just evaluate this expression and write the answer, right? Please don't do that. Please build the syntax tree and apply the semantic rules. Please don't just evaluate this numerical expression because the semantic rules may not be what you know in classical mathematics. I see that mistake being done by a lot of students. They just look at this expression and they'll say, hey, I'll just simply evaluate it. I mean, like a simple arithmetic expression. But you could fall into a trap that way. Okay, most of you got it right, which is good. Again, most of compiler design is easy. It's just lengthy sometimes, that's all. Okay, let me quickly answer this. Of course, the answer is 51, which is what you will get by numerically evaluating it also. But if some of these semantic rules are changed, your answer can go for a toss, right? So it's always good to avoid silly mistakes, because as you see in the last couple of years, gate examination is getting trickier, not harder, but trickier. They're just putting more cases where students will commit silly mistakes, right? So actually, let's use these rules to construct the whole tree, right? So L generates E, right? Okay, let me just draw it slightly smaller so that we can use the space here. L generates E. E will again just draw the syntax tree, right? So just draw the parser, basically the parsing tree. I keep getting confused with these terms. Okay, so E generates T. T can generate star. T can generate division also, right? So T can generate T/F. Okay, cool. I'm just looking for what all can generate my division and multiplication. So then this T can generate T*F. Now I think simple. So T will generate F now. F can generate a number, right? F can generate a number. This F can generate a number. This T can generate an F. This F can generate a number. This F can generate a number. Got it. So this is simple. So, okay. So let's go step by step. What is our first number? 7 here. This number is 7. So 7 into 7 plus 6 by 3, right? Just apply your syntax directed translation, right? So what does this say? This says f value equals to num.lex value. Somebody asked this question, sir, can you give me an example of what is a lexeme and what is a token, right? So here num is a token, right? It says that there is a number. 7 is the lexeme, right? Because this is like an expression in the code, right? So look at this. It says the num.lexical value. So 7 is the lexeme, num is the token here. Okay, that's the simplest way to understand it. Tokens are what your parser takes. Like your parser doesn't take the 7 into consideration. That's what your lexical analyzer takes 7 and says, hey, this is a number, right? And it creates this token called num, right? Somebody asked this question a while ago. So I thought this is a good time to discuss that. Okay, so f dot value is e dot value. So this is 7, this is 7, this is 6, this is 3. Now t dot value, where is t dot value? T dot value is f dot value. So this is 7, this is 7. Okay, so yeah, so when you have multiplication, what does it do? Again, if these rules are changed slightly, instead of multiplication, if somebody gave you division here, that's it, right? So please be careful to apply the rules carefully. We have seen questions where there is a syntax directed translation question like this, where they change these rules to be non-intuitive. Like here, everything is intuitive. Star means multiplication, front slash basically means division, right? We gave a simpler example here, but they could simply change it, right? To make it slightly tricky for you to follow, wherein you have to draw the whole syntax, the whole parse tree, right? So this is multiplication. So 7 sevens are 49. This is division. Okay. Sorry, this is 6, not sorry. This is 6, sorry. 6, 6. Okay. 6 by 2, 2. This is 49 because e dot val is t dot val. 51, 51, and you're done. But imagine the answer is 51, which is what you would get if you just solve this arithmetic expression. But even a single change here, imagine if this simply changed to square root. Let's just say, right? Then if you said 51, that answer is incorrect. So it's always better to avoid silly mistakes to draw the parse tree and then apply the syntax rules bottom up. Simple logic, right? Again, one very important thing one thing that I wanted to emphasize, because if you see some of these questions are easy, but I've seen one question where most of you have done a mistake, or a good chunk of you, I won't say most, I would say a good chunk of you have done a mistake is when you have to decide whether something is LL0, LR0, SLR1. So my strongest recommendation here is please practice. Please practice drawing this graph, right? In some books it's called a graph, some books it's called a finite automata. Please practice drawing this and please practice filling the parse table. Okay. It just requires practice. If you don't practice it, you will make mistakes. You practice it, you're done. Just follow how do you remember these steps eventually, right? You remember these steps if you solve enough problems. Like when I was revising compiler design before the whole live sessions for compiler design started, I actually went through the notes that we have. I went through step by step. I actually drew some of these parse tables because I forgot some of it. To be honest with you, I forgot some of the rules. Some of these rules are non-intuitive, while some of them are intuitive, some of them are not. So the best way to do it is to practice. Once you practice, you will not make mistakes, right? So please, please, please practice more here. Cool. So let me just change to the webcam view and let's get started with our questions, general questions that some of you have been asking. Okay, I'll just have my phone open. Okay. So some theoretical questions in compiler design are in much depth. Again, Kshitij, I don't know what you're talking about exactly. There might be one odd question in one question paper, but typically, again, if you see data flow analysis, right? Because last year was the first year when data flow analysis was added to the syllabus, they gave slightly more theoretical questions, right? But if you have gone through the core concepts of data flow analysis from our course videos or from the Dragon book, the famous Dragon book by Ullman, I think most of the questions were actually fairly easy to solve even from those topics. So somebody is asking about the scholarship test. There are two constraints. As soon as they're resolved, we'll conduct the scholarship test. One is for a lot of universities, the semester end exams are happening now. We reached out to some of our course enrolled students also to understand when their exams are. So once those semester end exams, especially for second year and third year, and also some final year students are over, they'll be able to, because the way we conduct a scholarship test is all the content for the scholarship test, for all of the concepts that are there in the scholarship test, we give all the concepts freely available to everyone, and then we conduct the test, right? So we're just, again, we don't want anybody to be at a disadvantage. Thankfully, the COVID wave, hopefully the COVID wave is behind us. There are parts of south of India like Bengaluru and Hyderabad is thankfully out of that wave, hopefully, but there are still lockdowns imposed in some of these cities. So as soon as we are out of that situation and as soon as most of the semester end exams are over, we will conduct it. Again, our scholarship test is available to even our course enrolled students. We are very clear about it. If you're a course enrolled student and if you get, let's say, in the top 100 ranks or the top 200 ranks, like just like last year, right, we would refund your full course fee. So there is no disadvantage for course enrolled students. Most likely, we will conduct it as soon as all the semester exams are over and as soon as all the COVID wave is slightly much more sensible, because we don't want any student to be at a disadvantage. We want to cover as many students as possible in terms of not having anybody at a disadvantage and everybody having a fair chance at it, right? Cool. So this is from DK. DK says, I'm not able to spend more than 2 hours because of job. I'm preparing for 2023, finished math and aptitude, guide me. DK, you're in a very good shoes actually. If you're spending 2 hours consistently at this point of time, and if you have completed already most of math and aptitude, I think you're in a very good shape that you can actually tackle GATE 2022. Don't give up on it. Continue your 2 hours. Mostly you'll be able to finish everything before the examination and also have enough practice. Probably from October or November, if you can squeeze in 1 or 2 more hours, I think you're on the right track. Don't think about 2023 right now. Think about 2022 first. Crack it. What's there? I mean, we have seen a lot of working professionals who have just put in 2 hours a day, successfully cracked it, right? Happily, they've got it in the top 300 or top 500 ranks. Okay, so don't worry about it. And given that you already finished math and apti. So test series, I think we've already announced it, right? It will be sometime in June. I've mentioned this almost in every session. So it will be sometime in June. We are just in the final stages of finishing it. As soon as it's available, we'll put out a video. As soon as we are done, we'll put out a video on YouTube. Sometime, again, I can't promise you an exact date in June, but again, I don't want to over promise and under deliver. So let's say just June now. So Subhanshu says, I got 584 score. Subhanshu, can you tell me your rank? Because I'm not good at processing scores. If you can tell me your rank, I can give you a better suggestion there. Is static single assignment not in CD syllabus? Again, one question about syllabus in general that we talk about is this. The GATE syllabus is actually very vague. They just say one topic and they don't go into the subtopics the way a textbook would go into. So the problem with that is, how deep should you cover the topic? Because remember, you have like almost 15 subjects. How deep will you go into, like if somebody says just code optimization, I'll give you an example, right? Or data flow analysis. Like we can teach a whole course on code optimization, intermediate code generation and data flow analysis. There are actually full length courses just on that topic, just on that single topic. Like because I took a compiler, I audited a compiler design course at Indian Institute of Science. I didn't credit it because I was too frightful, but I wanted to understand a little bit because it was taught by Professor Y.N. Srikanth, who is like a legend in compiler design at IISc. So his whole course is just those 3-4 topics, because he says in undergrad you learned all this syntax directed translation, all parsers, all of that. So let's focus on the other part. So the problem in GATE syllabus sometimes is they don't tell you the exact subtopics. So what do we do then? We look for reference in the previous year questions. Even GATE question papers that are set by IIT professors or IISc professors, they look at previous year questions for guidance on how to set newer questions, right? So even we do the same thing. We look at, like last year was the first year when we had questions on data flow analysis. From that we realized, okay, they're not asking too much. They're just looking for the basic understanding of it. Because we can spend like 20 hours just on data flow analysis if you keep going into the details of it. If you go to a course from a top university like IISc or Stanford, we can do 20 hours just on data flow analysis or intermediate code generation. We can go into how intermediate code generation is done for Python, for Java. Like you can go very, very deep into it. But it's a balance that we have to play in terms of what will give our students the most bang for buck in terms of the time, right? So that's a fine balance that we try to do. That's why, somebody's asking about a concept. We have never seen questions like that. That's why we've skipped it completely, right? Cool. Another very interesting question from Prateek. Prateek says, DLD syllabus is vast compared to number of marks. But remember, DLD, you can score 100% of the marks. I think after compiler design, our next subject is DLD. Because DLD is also just follow your Kano maps, simple steps, right? Your logic gates. It's actually, you can easily score if you don't make silly mistakes, especially with memory units. You can easily score, like even though you get fewer marks from DLD, you can easily score all the marks. That's the best part about DLD, right? Even the IEEE number representation, etc., they're straightforward. They're simply rule based, right? So please don't skip these subjects which are easy to score marks in, right? Because they can give tricky questions from other topics. Like for example, from algorithms or from data structures, they can give fairly tricky questions where you might not be able to score if you do silly mistakes or if you're not very good at problem solving. But from something like DLD, you can get like 90+% marks, even 100% marks in DLD. That's why we recommend you do that in the early days, right? Even compiler design might look a little lengthy because there are so many parsers, there are so many rules, there are so many steps that you have to remember. But once you do that, you get like almost 6 marks to 7 marks trivially in compiler design. That's like free marks. Okay. Cool. Okay, so let me just scroll down. So Subhanshu says, I got 2,297 rank. Okay. So Subhanshu, given that you're in that early 2000s, that shows that you have the concepts right, but you have significant gaps. Because to get into top universities, you might want to be in the top 300, worst case top 500, if you're okay with some of the top NITs, right? So we have seen people very similar to you, 2000, 4000, even 5000 ranks, who by putting in a little extra effort this year, especially focusing on areas, especially focusing on areas where they're lacking or where they have significant gaps, where they've not solved problems or learned the concepts, focus on that. And it's very, very possible. It's significantly easier for you than somebody who is doing their gate preparation first time to go into the top 300 or top 500 ranks. So I would suggest, if time permits, you should attempt gate again. That's what I would recommend, because you're already so close to it. Just a second, folks. Okay. Somebody says, Krish says, I want to start from June. Is it good enough time? Very good. Actually, a lot of students actually prepare their gate preparation in June, July. Most of them. Again, we have seen people who started their preparation in September last year, right, and successfully cracked it. So 6 months, if you put your heart and soul into it, consistently you can crack gate. That's like the simplest rule I can tell you. 6 months is completely sufficient to crack gate. Right? Even if you're just starting, you're not, like for an average BTech student or even a below average student, if you put in effort for 6 months, you can crack gate. It's as simple. If you're slightly average or above average, even fewer amount of hours and fewer or a shorter duration also can help you. Right? So Mallikarjun says, in today's situation, how can students manage online classes and gate course? Actually, it's easier nowadays, right? You don't have to commute to college. You're not wasting your time. Online classes in college and most of the coursework in college is trivial if you're preparing for GATE anyway. If you're learning for GATE, your core computer science concepts are strong, that even if somebody gives you a slightly trickier subject, like if you know programming well, if you know data structures, algorithms well, even if you have another programming language, it should be straightforward to pick up. Actually, even last year, a lot of students have used the lockdown of not having classes or having classes online to their advantage to put in more hours into the GATE preparation. Because like in a typical setup, right, you have to go to the college, you have mandatory attendance in some colleges, all that is overhead, right? All that is administrative overhead, travel overhead, all that is gone now. You can sit at home, attend the class, finish the class, prepare for GATE. Like it's literally like going from one tab to another tab, right? No commute, no waste of time. So actually this is beneficial for students. So Ayush says that you're already watching videos at 1.5x. That's actually pretty good. Don't worry about it. Don't try to finish everything in 2 months. Okay. Please remember that if you go through the whole flow, if you go through all the practice tests, all of it, don't be in a rush. Try to digest the subject, solve enough problems. We still have a lot of time before the GATE exam. I mean, I'm saying lot of time in relative to the average time that most students put in is about 5 to 6 months. So compared to them, you have a lot of time. Don't worry, you're watching at 1.5x, that itself is good. We intentionally teach a lot of our concepts a little slower because we're trying to even cater to students who are below average or significantly below average, because we don't want to leave anybody behind, right? What do you think about MS research at IIT Bombay? It's actually good. Again, it might take slightly longer because I think some MTech research programs take 2.5 or 3 years. But if you're clear that, okay, I want to learn, let's say, machine learning, or I want to learn distributed systems, or I want to focus on big data, the MS research typically has, at least at IISc, I think also at IIT Bombay, it has fewer number of courses that you have to take, but there is significant amount of research work which will prepare you better for research roles. Or if you're thinking of PhD, that's a great place to be, right? So it's actually pretty good. So don't worry about it. So Manzil says, my rank is 1050. How much effort should I put in to get into top 100? I think whatever you put in last year, if you put in the same, you should get it this year. That shouldn't be a problem because it's just an incremental hard work for you, right? I think those of you, some of you are there in that 1000 to 2000 range. I mean, if I strongly recommend that you reattempt GATE, because you've already put in this effort to get into that nice range. If you just double down those efforts even this year, there is nothing that is stopping you to get into the top 300, 400 ranks. How much subject can we do at same time? I think, Rahul, your question is how many subjects should we do simultaneously? I've always recommended that you should do one subject at a time, right? That's what I often recommend students, because then you can focus on one subject and be done. Go to the next subject, go one after the other, keep revising 2-3 subjects once you're done with them. That's a standard flow. I think I've mentioned this in every live session now in general questions. Is it good to do an MS after MTech? I mean, I don't know where you've done your MTech. I don't know where you're planning to do your MS. So I can't answer that question, Subramaniam. Without more details. How much time should I spend on aptitude? It's a good question. What a lot of our students do, what we also recommend is, if you're overwhelmed with some subject, because aptitude is also one of the easiest. These are like high school math problems, right? That we have been solving from 7th grade to 12th grade. Simple math problems like that. Actually, GATE aptitude is actually significantly easier than what you see in CAT or other competitive exams. So let's assume you have done TOC, CD, or you've done some subject that is overwhelming for you. You feel a little tired and you want a break after a subject, squeeze in aptitude. That's one idea you can do. Otherwise, if you're like, I don't care about it, I want to go every subject, you can have aptitude at the very end. That's also another strategy. The two strategies that we've seen students follow: squeeze aptitude when you're a little tired with your preparation, you want a little break from the hectic things, put in aptitude there, or do it at the very end. That's also perfectly all right. So how many times to complete the whole syllabus before GATE exam? I would say, this is from Nikhil, I would say do it thoroughly once. The first time you have to do it very, very thoroughly, solve the practice problems, all of it. Then you can do 2 to 3 revisions and you're good. But the first time you have to do it very, very well. Do it thoroughly, go through every video, solve every practice problem, make notes, or at least take the notes that we have, annotate it with your additional notes, highlight it, print it. Again, all these are PDF copies, so you can PDF copies, so you can quickly print them, annotate, write your short notes on top of it. Do it properly the first time, then just 1 or 2 more revisions. 2 revisions I think is more than sufficient before the GATE exam, if you have done it properly the first time. Okay, cool. So Ayush says most people say complete all subjects by September. That's not true. You can look at a lot of our topper interviews that we have on our YouTube channel. Many of them actually finished the GATE syllabus in December, some even in Jan. They just did 1 revision. But the first time they prepared, they did it very, very thoroughly. That's what is the key advantage for them, right? So again, we have had students who started their preparation in September and still got a good rank, right? So September is not a hard deadline. Of course, we have had students who finished their preparation in September also. But the more important thing is not when you finish your preparation, it's how well you have done it the first time. That is more important, okay? Is practice test sufficient for mathematics? It's a first start, right? First, please finish your practice tests, and then you have subject tests and things like that. Again, if somebody did not like our notes, please share your notes. With your permission, we'll put it on our website if it is good enough. We are happy to share notes that students share with us. So if somebody thinks our notes could be improved, please, we are happy. Let's try to do it more as a group thing in a collaborative fashion. Please write your notes well. We will review your notes. If it is good, we will put it up along with our notes. We'll give you full credit for it. Okay, please. We're always here. We always want to share these notes openly so that everybody benefits. Again, I've answered, again, people are also asking about test series. I've already answered this. No point in repeating the same thing again and again. I think I've answered most of the questions. Okay, Mrigank, okay, very interesting name. So you have a very interesting question, which is, Are course videos enough to get into the top 100 ranks or standard books necessary? Again, most of the course videos and practice problems are taken from standard textbooks, right? So if you don't have time, skip it. The course videos are more than sufficient to get into the top 100 ranks. If you do them thoroughly, if you solve enough problems, they are more than sufficient. Wherever anything is lacking, we keep adding content, we keep adding new things to it, right? It's more than sufficient to get into top 100 ranks easily. If you have time for additional practice, standard textbooks are always helpful. I would never say they're not. But if you don't have time, just go through the videos, you can easily get into top 100. I think somebody's asking about top 200. When I say top 100, top 200 is obviously, that's an obvious answer. So Priyanshu says, which gate scorecard will be valid if I attempt gate multiple times? I think you can choose whichever has the best score. I think that is true from the administrative side. Like for example, if I write gate third year and final year, and if let's say my third year score is better, I think I can use it after my final year. So there is no restriction that the most recent one needs to be used. I don't think the most recent one needs to be used. Again, correct me. This is what I remember reading in the GATE official brochure last year, but correct me if I'm wrong. Somebody saying AAR for IIT Bombay is decreasing. What AAR are we talking about? What AAR are we talking about? Again, I mean, students always choose between IIT Bombay and IISc, so it's a choice they have, right? This is from an LES called Celebrating Life. Any suggestions for preparing for ISRO scientist? Again, if you prepare for GATE, I think a good chunk of the ISRO syllabus is catered for. ISRO exam is at the GATE level. Sometimes it's also easier than GATE level. So most of what you have in the GATE covers most of the ISRO syllabus. If you're preparing for GATE, ISRO is taken care of. There might be some additional topics in ISRO exam, so you might want to just refer to standard textbooks for that. Okay. So the All India rank for IIT Bombay is decreasing every year. No, it's not. It's not actually. The number of seats are the same. So it might just so happen that people are preferring to go to IIT Bombay rather than other IITs, or probably IISc in some cases because they're not interested in research careers. That's it. The number of seats I don't think have reduced, for MTech at least. Sounds good. I think I've answered a bunch of questions. There is a lot of repetition of, no point going through the same things again. Again, this video will be available on YouTube, so please check it out, and all the very best. Stay safe. That's the most important thing right now. Bye-bye.